Video we put out last year, Microsoft, where it's a clip from an advertisement we did at the Super Bowl last year.
My name is Estella Pfeiffer, and I am the founder of Estella's Brilliant Bus. We travel to low-income communities where many of the families do not have computers. It's always good to go back and reread the.
So when you and I watch a video like that, a lot of the stuff is sort of unconsciously intuitive. You know, there are people in this video, you can recognize someone, so if Estella appears in more than one clip, you see her in the first clip and you know who she is in the second. You understand the text, the audio, and stuff that you don't even think about noticing, like the color of pictures or related contents. The bus goes on a road. That stuff to you is totally intuitive, and for a computer, historically, has been totally obtuse, something that computers have no access. And the great thing about Microsoft Cognitive Services, there are a set of APIs and SDKs that democratize this kind of intelligence, that make it extremely easy to use some of the best research that's being done at Microsoft Research, some of the work that's being done at Bing and in our Cloud and Enterprise division to take machine intelligence and make it simple. And so we have kind of three big things. So the first is they're easy. These are REST APIs and SDKs. You can get started for free. Everything has been designed to be extremely simple and straightforward. They're off-the-shelf solutions for common kinds of scenarios and problems. They're flexible. Since they're REST APIs, you can work in the language of your choice, and they're tested. They've been, the same technology has gone into lots of different kinds of Microsoft products, Microsoft Research offerings. So this is sort of the three reasons to consider Microsoft services.
So as we think about Microsoft's offering in artificial intelligence, this isn't a new thing. Microsoft Research itself has been around since 1990. Gallery to Windows Hello, where you can use your face to authenticate yourself into your computer. But sort of what we're trying to do with cognitive services is decrease the how this works today. We have a research team, and they work really hard, and they write all of these papers. And then eventually it gets to the product team, and the product team works on it, and they bake it into the product, and they ship it to the customer. And the customer is super happy, and he rejoices. But what we actually did with cognitive services, we're like, OK, let's take a step back. How can we make this easier and faster and not hit that button? So we took the research, we made it into a set of APIs. And so not only does this mean that we can get this great technology into the hands of our customers faster, we can have more happy customers, and they can go build their own applications and get happy customers for themselves. And as Anna was saying, this is the same technology that powers a lot of our products, from Skype to Office, Windows, Bing, Xbox, and more. You're using the same algorithms that these products are using today. So let's actually go deeply into the different APIs, the different areas we have. There are 5. We have Vision, which is all about understanding images and videos, speech, where you can understand people, language, knowledge, and search. So we're going to jump into them now.
So the Vision category. Before I get started, I want to call out one thing, which you'll hear us say 18 times during this presentation, because it's the most important thing we're going to say. You can get started today with these 22 APIs for free at Microsoft.com/cognitive. So if you get one thing from this presentation, it's that everything we're about to show you, you can start working on today. So Vision. One of our core Vision services is our Computer Vision API, and this helps you distill actionable information from images. So we can take a look. At the sort of Vision demo available on our website. And here we have this image, and you can see there that it's calling out that this is a man, and likely who's about 28, and his gender is likely male. So we're calling our Face API here, and you can see the tags. So we think that this is, with very high confidence, an image of water, sports, swimming, pool, water sport. So you can take images and actually get insights about what the content of those images actually is. In this other example, we actually generate a caption for you. So we think this is the image. This is a person waiting at a train station with reasonably high confidence, and that person's kind of blurry, so it makes sense that there's a medium amount of confidence. But what you're able to pull out of here is a sort of very deep level of understanding of an image. And a cool thing about this API is the technologies actually were built by the team that won ImageNet this year, which is sort of the most prestigious competition in image labeling or academic machine learning around computer vision. In addition to sort of labeling, finding objects, you can also do things like identify whether or not an image is adult or racy, which is used in Microsoft content moderation, and information about the colors, sort of the type of image it is. We also have Face API, so as you saw earlier, you can find somebody's age and gender. You can also do general face detection, tagging faces, identifying faces, so you can have sort of a concept of a person and see, is this photo of this person? Emotion API, which is one of my favorites, in part because I work on it. So how do we do that? Well, it turns out that psychologists have, for years and years and years, done a bunch of research about what kinds of facial expressions have different types of meanings. And that there is a set of facial expressions that are sort of universally identified with a set of emotions, like cross-culturally, any age, any person, we all pretty much smile the same way. And so we've used computer vision to identify people's emotions or make an inference about what their emotion is based on their facial expression. And the really cool thing about this API is it's actually a great example of the way that Microsoft Cognitive Services is taking cutting-edge research and turning it into services. So this API came out last November, and it came out 2 days after the paper was published. And the reason we got that really quick turnaround is that the team was embedded with the research team from the get-go to make sure that we could bring you a literally bleeding-edge service, something that we had just been published about the first time. And we had an update this week at Build for the sort of emotion recognition sort of model, but all the cognitive services are getting regular updates so that they are really cutting-edge APIs. And then our video APIs help you do analysis, editing, and processing. So if you've seen, for example, Microsoft's Hyperlapse application, we use sort of hyperlapse stabilization to help you stabilize videos.
The next class of APIs are the speech APIs. So I can use these to communicate with my users, understand what they're saying, and then speak back to them using voice. And so the first one is Bing Speech API. It's powered by Bing. It does just this. But I think which is really interesting is speaker recognition. So speaker recognition goes a step further. And it can say not only is someone talking about cognitive services up here, Allison Light is talking about cognitive services. And there are many applications you can use this for because your voice is actually like a fingerprint. Everyone's voice is unique. You can use it to authenticate. We actually have one of our hackers built a little component that he put on his door, so when he comes home from work every night, he says a secret passphrase and it only opens with his voice because it knows Chiffon and not Allison, and I've tried this and it doesn't work. But we can actually do an example of this, again, on the website. So if we go back to our Edge browser, here we have our demo where we have preloaded a bunch of sound clips for the presidents. So I'm going to play one, and then we're going to see if it can correctly light up which president is speaking.
We gather because we have chosen hope over fear.
It looks like the audio is not working correctly, but you can trust me in that it actually did start saying Obama's speech, and it was able to correctly detect him.
And false promises, the recriminations, and worn-out dogmas that for far too long have strangled our politics.
It's there.
We remain a young nation.
And let's stop that now. Okay. The other API in this category is CRIS, and that stands for Custom Recognition Intelligence Service. And this was mentioned earlier today at the keynote, where it had the kids' voices and analyzing them. So you can see that with regular speech-to-text, it does a really bad job. But if you use a CRIS-trained model on these clips, it can actually decrease your amount of errors by a significant amount. And with the kid example, it's interesting because kids speak a lot differently than adults speak. They have, they're still forming their words. They don't really know how to say things correctly. But this is also really good for custom vocabularies. So think about a hospital, right? If I'm in a hospital, there's a lot of background noise. There's machines beeping. There's a lot of ambient noise of people talking. But there's a very specific vocabulary used in a hospital. 100 milligrams of ibuprofen, for example, is probably not something you say every day, but in a hospital, this is very common. And so what you can do is you can use CRISP, you can train it on this hospital and medical specific vocabulary, and actually build a system where you can detect people's speech really easily. And that's super powerful, and it's bringing your own data to light up your scenario.
So moving past speech, we have language. And these services actually very often pair well with speech. So you might do, speech to text and then sort of do a set of language services. So a bunch of these APIs kind of will work well together. So the Bing spell check API is quite fun. So you might think, well, I have a spell check in my app, or I already use a speller, I've got a dictionary. But it turns out that words get, change spellings really quickly. So a few months ago, I was looking at a word in a document spelled Lyft. And since the document was in a processor that wasn't using the Bing speller, I thought this was wrong. But actually, capital Lyft is a thing. It's Lyft. It's the app I was using to get a ride. And so the Bing speller is updating using data from the web to get new persons, new categories, new businesses, so you have an always up-to-date speller. Web Language Model API is a web language model trained on web scale data. So if you want to do something like auto-suggest, or you want to sort of make a keyboard where you recommend what word should come next, you can use something like WebLM. Linguistic Analysis API is for people that want to do some more in-depth NLP, natural language processing. So you can sort of parse complicated texts using some state-of-the-art natural language processing tools. Language Understanding Service, which we call LUIS, is probably my favorite API that we're going to talk about today because I have yet to meet a developer who doesn't have a need for LUIS. So the purpose of LUIS is to help make it easier for you to build apps that have natural language interaction. So for example, let's say you wanted to have an app and you could ask it questions about sports statistics, or an app to control your house, and you wanted to be able to say, turn up the lights and turn off the stereo and turn the temperature to 73, or it's hot in here, turn it down to 73. You could sit down and write down every single possible phrase that you think somebody's going to say and do an inordinate amount of work to get all of these phrases and build your own language model. And this is time-consuming and it's data-consuming, and it takes most developers weeks or months. LUIS helps you do this for most of our ISVs in hours. So let's look at an actual example. We have in here that can kind of help you understand. So LUIS is organized around the ideas of intents and entities. And so here's an example of an application where I want people to be able to do two kinds of things. I want them to be able to book a flight or get the weather. And the entity concept that I have here is location. The cool thing about LUIS is that you're actually getting all of the Cortana language models for free. So stuff like dates and times and like geographical locations, you get all that for free from Cortana. So you don't have to do any of that work in the first place. But I have this idea of booking a flight. So I might say, I have to train LUIS, a LUIS model, I give it a couple of examples. So I might say, get me a flight to Toronto tomorrow. I hit enter. And LUIS thinks with 94% confidence that this means book me a flight, which is correct. And it's 0% confidence that this means get weather, which is good. So I'm going to hit submit here. And now I can publish an updated model because I've given it a new piece of data. And also give it a query to check. So let's say, fly me to Miami tomorrow. I'm doing this on the fly, so we'll see how this one goes. We'll query. And unfortunately, LUIS didn't get this one right. It thinks that the intent here is none. But that's OK, because I can actually go back now, that it's received this intent, and review a set of labels. So we'll let this sit. But basically, when you get utterances like this that you don't necessarily recognize, you can go back and say, oh, that was or that wasn't right. And the nice thing about LUIS is it'll bubble up to the top things that were really low confidence or things that you hear a lot that you haven't labeled. So you can very easily put together you can very easily sort of train your system and take an incoming data without having to spend an inordinate time having a human look at every single utterance. You only need the human in the loop for places where you really need the update to your model. And so LUIS makes it extremely easy to make these custom language models. And then Text Analytics API is another super popular API. So this one lets you do things like detect sentiment in bodies of text, extract key phrases or topics, or get language from your text. So for example, if you have customer feedback coming in, you can use Text Analytics to both look at the sentiment and say, what is the topic of this piece of message, like this message that I'm getting back, and maybe use that to help you decide, well, who do I forward this particular piece of feedback to?
The next class of APIs are the knowledge APIs. And what the knowledge APIs do is it enables you to connect concepts within the world and derive meaning from them. So the first one I'm going to talk about is Academic Knowledge API. And the specific context that you're going to receive here are being able to index a whole bunch of papers and journals and authors from academia and be able to find these papers really effectively. But this is just one example of a knowledge graph. It's a very specific knowledge graph. What if I want something that uses my data and connects my concepts and my domain information? Well, that's actually what the Knowledge Exploration Service is for. So you can bring all of your data to this product and actually create that graph for yourself and be able to index on what's specific to your problem and your scenario. The next API is the Entity Linking Service. And what you can do here is understand what concepts, well-known concepts exist for free, and then be able to pull up a Wikipedia article associated to that. So I'm going to give an example here. Again, back on our website. We really love our website, in case you haven't seen that yet. But I'm on the Entity Linking page, and I'm going to do a sentence and see if it's able to detect it. And I'm going to be a little evil here. I'm going to try something hard. I'm reading the New York Times while in New York Times Square, right? And so when I do this, you see that it's able to detect these two things, great. And if I look at the JSON, that there are actually two separate entities for these. And so it did a great job with that. And then the final class, the final API here is the Recommendations API. So the Recommendations API lets you build a really robust storefront based off of how people are using your products and buying products. So we can do things like similar product suggestion. Say I really like pogo sticks, I want to go back to the 90s and the 80s, but I want to compare the different pogo sticks, right? How do I know that this manufacturer makes one better than this one, or vice versa? And so you can do that. Or you can do similar product suggestion. So say I'm buying a coffee filter. Say I'm buying a coffee maker. I'm going to be really upset when that coffee maker comes and I forgot to buy coffee filters. And so using this API, it connects your data and watches what people are doing. So you can actually build that storefront really easily and not have to spend hours on algorithms to just get you there.
Search. So we're super excited. Today we came out with Microsoft Cognitive Services, and one of the big additions has been in the area of search APIs. So there's the Bing Web Search API, which connects you to web search. So in your app, you can surface search results. You want people to be able to look up content or information. Auto suggest, so you get intelligent auto suggest that comes straight from Bing. Image search API, which is actually super cool, because what it does is you can do an image search, you can see in your application, what are the top images that come up in this image search. But a really nice thing about Bing is that the team has done a ton of work in making sure that the images that come up are both the most relevant images for a particular set of keywords that your users are searching for, but also the most beautiful. I'm not even kidding, the Bing team has a team that optimized for figuring out what makes a photograph like a high-quality photograph, what makes it beautiful. So we're really surfacing photographs will make your apps look good and get people photographs that they want to see. The Bing Video Search API, so same thing but for video. You can have someone search for something in your application and pull up in a window a list of videos. And the Bing News Search API, so you can get people news up to date in your application.
So that was a lot of information. 22 APIs isn't something to just laugh at. And we went over vision, speech, and language, and knowledge, and search. But what can we do with these APIs? Well, let's actually code up an example. So earlier in January, we released this app called Mimicker Alarm. That's my face up there, making a happy face. And what Mimicker does is it's trying to help you reimagine how we can live our world if we use artificial intelligence in our apps. So it's a very simple alarm app. And the only trick is to turn off your alarm, you have to play this game. And if you don't, the alarm's going to go off forever. And we're resilient and we don't give up. You literally have to do what we ask you. So there are 3 different games you can play. The first one is called Express Yourself. So we give you an emotion, and you actually have to make that emotion. When you wake up, people, turns out, aren't really the happiest, so that one's challenging. There's Color Capture, where we say, take a picture of something blah, and we use the computer vision API, accent, and dominant color detection. So for example, this is a plan to my living room, so I actually have to get out of the bedroom and take a picture, and I'm not going to sleep after that. And then the last one is Tongue Twister. And so this is an interesting take on the speech API, where we're not only just transcribing what you're saying, but checking, are you saying the thing we expect you to be saying? Which means you actually have to say, how much wood would a woodchuck chuck if a woodchuck could chuck wood? Instead of, I hate your alarm, please stop, this is terrible. So what we're going to do is we're going to code up eyes open and closed. And what we're going to do with this is we're going to use the face API and pull out all of the features on the face. And when I talk about features, I'm talking about the points. So you can see here that these are the 27 points we map. And what we're going to do is we're going to take the ones around the eye and then figure out the ratio of those points and make a guesstimate of, do these eyes look open or do they look closed? And you actually have to take a picture of your eyes open wide enough in order to pass the alarm. So I'm going to switch over to Android Studio. Our app is in Google Play Store today if you want to check it out. And I've already actually done a lot of work to make a new class. I'm just going to focus on the cognitive services part of it. And so I got my key from Microsoft.com/cognitive. And the first thing I'm going to do is actually initialize my Face API client. And what's really important to note here is that while we do have REST APIs, we have SDKs for a lot of the platforms to make it really, really, really easy to start coding. So before this talk, I just went into Maven and put it into my project so I can have a more object-oriented way of interfacing with the APIs. So I'm setting up my subscription key. I created my REST client object, great. And then we're going to go to this verify function. So what verify does is it passes in the picture it took from the camera stream, and then we have to actually check, well, did they open their eyes correctly or not? So now that we have the camera bits, this is code that's not super interesting to us, we're going to make the call, which is what we do care about. So again, I'm going to auto hotkey it, so you don't watch me typing and failing up here. And we're setting up our parameters, and then we're going to make the call. And the 3 parameters that you can pass are Face ID. You can use this for recognition and actually get back, okay, this is a specific person, they have a specific face geometry, and I can use that if I want to do similar face searching, but here I don't really care. We have return face landmarks. These are those dots on the face, and so yes, I do care about those. And then the face attributes. And what face attributes does, it actually tells you a lot about the face. So you can know your facial hair for your mustache, beard, and sideburns, and the length of your facial hair. You can know whether you're smiling or not. You can actually know if there are glasses on the face. And while these are all very interesting, we actually don't really care about it for eyes open closed, so I'm just going to pass false. I'm going to make the call, and then I'm going to store it in this face landmarks object. And now I'm going to have a very verbose way of pulling out the points. But for completeness sake, go over here, and then pull out all of the X and Y coordinates for the eye, and then actually calculate that ratio for each eye left and right. And then I'm going to do a really simple check of what that ratio is. And I did a bunch of testing before this, and I found that 0.4 is actually a pretty good ratio for checking whether your eyes are open or closed. And if you're not open enough, we're going to say you look too tired, try again, and if you did a good job, then we're actually going to let you go on and live your day. So if I switch over to my phone and not show my password. So here's my little dev version of the app. I changed the header. It's usually bright and sunny. But when you're coding, I like to do it at nighttime so it's dark. And I'm going to make a new alarm. In here you can see I can customize in a bunch of different ways. I can pick all of the different games I care about. I know randomly select which one, but I actually only want to do eyes open, and that's selected. Great. So let's set the time to 14:38. And now we have this really awkward time in the presentation where we have to wait a minute for the alarm to go off, so we just stare at each other in silence.
Well, Allison, I have a question for you.
Oh, what is
This
it,
is pretty
Anna?
cool, and I also want to build my own Mimicker alarm modules. Can I do that?
That's a great question. So Mimicker Alarm is actually entirely on GitHub. We open source the entire thing from day one. So you can go and pull the source code and make your own app or build new games. And we are accepting pull requests. So you can do that at any time, and we very much welcome contributions. We actually, oh, look, there it goes. All right, so I'm going to dismiss it. And then I have this timer at the top of the screen where I actually have to finish beforehand. I'm going to pick it up for a second, take a picture of myself. I'm not really a morning person. Let me try that one more time. So yeah, I'm not super morning person, so I'm gonna have to try again. Let's do eyes wide open. That's terrifying. Get excited. Oh God. But I did it. And after this, you can share your photo with all your friends and family on how you woke up. I probably won't for this one. But the point here is, alarm apps are really simple. All of us probably use an alarm to wake up in the morning, but think about how it could be different if you are able to use artificial intelligence really easily. And you saw, all I needed were a couple lines of code to do this, so any developer can do that. So if we could switch back to the computer.
So, any developer can do it, and some developers have. So we had VisuGlobe, who you might have seen the keynote talked about a little bit, has been using our Vision API. And so the scenario that they're using it for is looking at social media feeds, and a brand may be interested in, well, what kind of people are tweeting about my brand? What's in the photographs that they tweet? What do they do when they put up a photo? And so, historically, you could have had your brand manager sitting there being like, all right, hashtag my brand. These photos are pretty cute. I'll write down what was in them. Not very efficient. And so the nice thing about Oxford API, the Microsoft Cognitive Services APIs, is that they make it easy to do stuff that historically has taken an inordinate amount of human work and let you do them with a computer. And we were very happy to see this quote from the CEO of VisuGlobe about how the reliability of Microsoft Cognitive Services makes it compelling for them to use our services. So we actually would hope that we'll have some time for questions, but we're also hoping if you guys have some questions or you want to check out some more demos, we will have an IPAs for APIs thing at our booth. So we're in the Intelligent Services area at 6, so that's right over there. We'll be there, happy to take questions. And before we go to Q&A, one more call out that you should get started for free at microsoft.com/cognitive. So there are a ton of demos that you can try out, but like we said earlier, the goal of the APIs is to make them super easy for anybody to use. And we, of course, appreciate any feedback you have on them. So I think we have some time for questions. Questions? Sure. So the question was about, it's free to get started, but is it a product? It's a good question. So if you go to projectoxford.ai, very long day, guys. If you go to microsoft.com/cognitive, you'll notice that there's a pricing tab there. And so you can take a look, and some of the APIs are currently available in the Azure portal, and over time we'll be adding more APIs to the portal. So I think right now face and emotion and speech and a bunch of the others are there right now, and we have some current and future pricing listed there.
And just to add on to that, if anyone's interested in further pricing or specific API, there's actually a contact us button on that sheet, and we do encourage people to contact us. Any other questions? I know you're dying inside. You're I'm just so full of questions and wonder from this.
Yes. Sure. So the question was about the example for the video. So we had that sort of like semi-live demo with a video emotion. So in that particular demo, we're actually doing multiple calls to our image API. So the emotion API has an offline video API. So that's primarily used by people that want to, they have a bunch of video of like focus groups testing products, or people watching television pilots, or crowds watching talks, and you want to see how the crowd has responded. You guys should all smile. And so if you have a need for offline processing, you can use the Emotion for Video API. And if you are just doing sort of individual images, or you want an effect like this where you're calling the API in sort of semi-real time, then you'll use the image API. Sure. So across the different services, there are different levels of localization. Speech is available in a boatload of like 13 languages for speech.
Yeah, Speech actually just pushed an update for Build to increase up to 11 languages. That's really exciting.
Lewis, I think, does English, Chinese, Spanish, French, and Italian, but don't quote me on that. So across different language APIs, there's sort of different sets of languages, but obviously we're interested long-term in broader localization.
And something that I would really much encourage you and everyone else to do is we do have a user voice forum where we're tracking feedback requests. And so if there's a language you're specifically looking for in an API, like definitely file something there so we can look at it and get it on our list of items.
You're going to have to shout. Sorry. My hearing is like not good.
So right now, we don't have a place that specifically publishes the white papers we're working off of, but it's something that is in the works. We just didn't get to it in time for Build.
If you wanted to be really crafty, you could go to the Microsoft research page, and for many of the APIs, with like a little bit of searching, it like becomes pretty obvious what the sort of background technology is. So if you are enterprising, that would be my suggestion.
Great. Well, thank you, everyone, for coming, and definitely stop by our booth right over here after the talk.